Wasabi, you guys. Welcome to Integration B for Intermediates, Part 12. In this section, we will be going over reverse product rule and reverse quotient rule. The last time, we kind of covered just like a surface level, beginners cases of these reverse product rules and quotient. Well, a little bit of quotient rule, but we haven't sort of gotten to like the nastier side of reverse and quotient rule, where you have to find or guess experiment with functions that can fit with these integrals. So let's go ahead and recall some of the basics. So here, you should immediately see that this is a reverse product rule and that you should already know what the answer to this is. And so, of course, this is reverse product rule. So your answer should immediately be sine of x, ln of x plus c. Okay? A lot of the times in competitive types of integrals, they like to use reverse product rules with e to the x because it looks hidden, and right here it doesn't look like reverse product rule, but this is reverse product rule. Here we see that if you notice, if you experiment by deriving e to the x cosine of x, then of course e to the x will always be e to the x. So because f is equal to f prime for e to the x, this product rule is going to look like this when f of x is equal to e to the x. Okay? So pretty much, I guess, a better way to write this is that when we derive e to the x with some function, it's always going to be e to the x of f plus f prime. Okay? In this case, we have cosine of x and then the derivative of cosine of x, which is negative sine of x. Here, we notice that it's the other way around. So of course in this integral, it's negative e to the x cosine of x plus c. So experimenting or testing derivatives helps us catch missing coefficients like this, like a negative sign or some number. So here, because I see that square at the bottom, this looks like quotient rule. So for quotient rule, when we derive f over g, it is f prime g minus fg prime g squared. Now, because this is square, I'm going to assume that g is equal to 2x plus 1. Then my g prime is equal to 2. Okay. So now, what is my f? What is my f? So that f prime of g minus fg prime is equal to x e to the power of 2x. Well, I already know what my g, 2x plus 1 minus fg. Oh, that looks like a function. Oof. Be careful with your notations. Here, well, we have e to the 2x. So why not try f equals e to the 2x, right? That looks reasonable. Again, I don't know what I'm doing. I'm just experimenting. So if that's f, then this must be f prime, which is 2e to 2x. So now if we plug it in, we want to make sure that this is true. So we go ahead, just plug it in, 2x, g is 2x plus 1 minus f e to the 2x, and g prime is 2, so times 2. Here, if we simplify it, we get 4x e to the 2x plus 2e to the 2x minus 2e 2x. This cancels out. Oh, so here it does not equal this, but That's only because of this coefficient. That's all we need. So we just need a 4. And so we just do 4 1/4. So now that we know what this is, we know what f is, we know what g is, right? In reverse quotient rule. So our answer is 1/4 of e to the 2x over 2x plus 1 plus c. This is how we do reverse quotient rule at intermediate level. Sometimes it's not so obvious, and so you're going to have to experiment with functions like this. And this is what we're going to practice in this section. So again, it's not really clear to what's going on. It looks like a quotient rule, but is it really a quotient rule? So here I see that ln is being squared here. So I'm going to let g equal ln of x. And of course, g prime is equal to 1 over x. Now, notice that our f prime g minus fg prime, we want this to equal to ln of x minus 1, so that it fits. But what is our f, is what we want to look for. Again, experiment, right? Well, we have g prime, and that's 1 over x, but here in the numerator there's no fractions, so it must have been cancelled out with x. So of course, try f equals x. Then f prime is equal to 1, and then we get ln of x minus fg prime. That becomes, let's see, fg prime. Oh, that's 1. That's exactly what we got. There you go. So now f of g is our answer, which is x ln of x plus c. Okay. In fact, this is actually one of the most common integrals that pops up in integration bees. So this is one of the integrals that you should be aware of. Again, this does not look obvious. This definitely does not look like a reverse product rule. Well, we have a bunch of ln's, so just to make it easier for ourselves, let u equal ln of x. Then e to the u is equal to x, and e to the u du is equal to dx. So now we have sine of u plus cosine of u, and then e to the u du. Oh, would you look at that? Now that looks like a reverse product rule, right? Because of this thing here, f plus f prime. That's exactly what we have here. So this is e to the u sine of u. It's a reverse product rule. And then we just plug in u equal to ln x back. This gives us x sine of ln of x plus c. Just like that. Immediately, I think this might be a reverse quotient rule because the bottom is squared. Right. So my first instinct would be, okay, so g is equal to 1 plus ln of x. Then g prime is equal to 1 over x. Okay. And I need to find f so that f prime minus f prime g minus fg prime is equal to ln of x. But how? How do we find this? F prime g is 1 plus ln of x minus f and then 1 over x to equal ln of x. What could this be? What could f be? I noticed, well, ln of x, there's no fraction here. There's no fractions here, and there's a fraction here. If I let f equal x, then I get this. Now let's see, f prime would be 1. So 1 plus ln of x. This would be 1. Oh, this cancels out. Oh, this gives me ln of x by itself. Cool. So f is equal to x. This works. Alright, so then, in that case, because there's no coefficients, it exactly equals ln of x. There's no coefficients. So this is equal to f g. It's a reverse quotient rule. this would be my answer. Okay? What do we do here? This looks weird. This looks very weird. So, what do we do? It's a bunch of roots. Let's see. I mean, this reminds me of, well, I mean, square root of x, the derivative of this is equal to 1 over 2 root x, right? And if we derive square root of ln of x, it looks like this. Oh, and we get 1 over x. Huh. This looks a little suspicious, don't you think? Well, is it this? Is it this product rule? Well, let's find out. So then, let's see, we got square root of x. That's 2 root x. And then square root of x. Now we're deriving square root of ln of x, which would be 2 root ln of x here, times 1 over x, because chain rule. Huh. Oh, would you look at this? That's exactly what we have here. For this, here, and this cancels out. Oh, I'm sorry. Well, not really cancel out, but this becomes a square root when simplified. And the only thing is, we just don't have a coefficient here, right? So we need a half. And then times 2. And so now, our answer is 2 times the square root of x ln of x plus c. Oh god, this looks like a mess. This is monstrous. Okay, so quotient rule, I see. So g is equal to x cosine of x minus sine of x. Then g prime is equal to, let's see, so it's negative x sine of x. That's what that is. Alright, now I'm just going to delete this. Okay. But that's still painful to look at. Okay. And for some reason, fg prime, not plus, minus fg prime, f prime g minus fg prime is equal to sine square. Huh. That's very difficult. How do we approach this? We need to find f where this fits. Okay. F prime. We have g. And then minus f. And then g prime. Huh. So I'm gonna have to put this in multiple colors. Or actually, it's kind of hard to say because you want to simplify, you want to find f where it simplifies to sine square. But how do we find that? Well, to make it easier, actually. So this negative, make it a plus. So it's just x sine of x. And then, huh. Let's see. How can we, there has to be some cancellation here. Right. There has to be some sort of cancellation here. Notice that we have f prime of x cosine of x, and we have f of x sine of x here. If I want these two to cancel out, then what if we let f equal cosine of x? And the reason is because this becomes f prime of negative sine of x, right? We'll end up with like sine x times cosine sine of x, right? Will they cancel out? It seems so because this is positive and this becomes negative, right? Oh, and look, f prime times negative sine of this gives us sine squared, which is what we need. Aha! So we found our f. F is equal to cosine of x. Alright, cool. So f is equal, our f is equal to cosine of x. And so now our integral is f over g, which is cosine of x over x cosine x minus sine of x plus c. And there you go. Very difficult to do. It takes a lot of practice. Try to look for cancellations. If that doesn't work out, you're just going to have to keep experimenting. Okay? This looks like product rule. Like ordinary reverse product rule. So we can test out, if we simplify this, we get x to the negative 4 plus 4x to the negative 5. Yeah, that seems about right. It's just we don't have a negative, and I think it's because of this negative x. So we can test it. If you're not sure, test it. Better safe than sorry. So e to the negative x times x negative 4. We get times negative 4 x to the power of negative 5, and then plus negative e to the negative x to the negative 4. This is exactly what we have, we're just missing a negative sign. So the answer, oh, I don't know why I did that. So the answer is negative e to the negative x times x to the power of negative 4 plus c. We have reached the MIT style integrals, and this one looks nasty because both top and bottom are squared. So what do we do? This looks disgusting. So I don't like this. I think I prefer to see e to the x's than ln of x's. So let u equal ln of x. And so now we get u minus 1, u squared plus 1, and then e to the u du. Okay? Oh, I'm sorry, squared. Don't forget about that squared. Okay, so to see what's going on here, let me go ahead and sort of simplify this. So we have u squared plus 1 being squared. And then u minus 1 is u squared minus 2u plus 1. Okay. And I see u plus 1 here. This looks like, let's see, with u squared plus 1, I want to cancel that out. So pretty much what I'm doing is, we have this, and I want to sort of split it so that to cancel this out. Huh, what does that look like to you? That looks like reverse product rule. It looks like it's this, and then deriving this gives us this. But where does this minus come from? Well, it comes from this, because it's a reciprocal. So of course we're going to have a negative here, right? Because 1 over x, if you derive it, you get negative 1 over x squared. It's a function, So that's how this negative comes. Okay. So that means that this is a reverse product rule of e to the u squared plus 1. Now we just plug it in. This is simply x of ln square plus 1, and then plus c. And that's your answer. I gave the last integral the hardest integral. And this is a very difficult quotient rule integral to see. So here we don't go straight forward to quotient rule because there is none. It won't work. So the trick here is that you actually do minus x plus x, and that results to x over x minus inverse tangent minus 1 squared dx. And if we simplify this, we get x squared of this minus 2x, x minus inverse tangent of x, plus 1. Okay. But definitely combine these two though. And so I'm probably going to need more room. So now when we combine them, right, multiply this top and bottom by x minus inverse tangent, you should be left with this minus 2x plus 2x inverse tangent, and then x minus inverse tangent squared. This should be 2x squared. So that's exactly what we have. Now, how do we find this? Reverse quotient rule. So g is equal to x minus inverse tangent. G prime is 1 minus 1 over 1 plus x squared. And this is actually the same thing as x squared over 1 plus x squared. And we want f prime g minus f g prime to equal the numerator. And notice that there's no fractions. There's no fractions. So that means that because g prime has a fraction, do you think f must be 1 plus x squared so that it cancels out? Let's try it, right? Let's try it. We're gonna need more room though. We're gonna need more room. Trust me, we're gonna need more room so that fg prime is no longer a fraction, just to cancel this out. So then f prime fg prime is equal to, well, f prime is 2x, and then g is x minus inverse tangent, and then minus f x squared plus 1, and then g prime, of course this cancels out. So now we're left with 2x squared minus x squared minus 2x inverse tangent. So we get x squared minus 2x inverse tangent. But our numerator is the other way. Okay, so it works, we're just missing a negative. Got it. So our answer is negative f over g. Cool. So, oh, careful, wait a minute. Plus 1. Be very careful. Plus 1. We went a little too fast there. The answer is x minus f over g. Okay? Be very careful. So now our answer is x minus our f was 1 plus x squared, and our g was x minus inverse tangent. And that would be our answer. So that is it. That's reverse product rule and quotient rule. Again, practice with experimenting. I would suggest to, how I always usually say, just rewatch the video and try the integrals yourself so that you can recall some tricks and you'll become more aware and more experienced with these techniques. Thank you so much for watching. I hope you guys find this helpful. I'll see you guys in the next section.